This is Chapter 4, Section 1 in College Algebra. We're dealing with one-to-one functions and inverses. Now, if you would like some other videos on this information, you can go to Khan Academy, which is at khanacademy.com. It has a lot of videos on a lot of different topics, and college algebra is one of the subtopics, and then this and many other things are in there. Okay, if we're starting to deal with one-to-one functions, a function is one-to-one if the letter y does not ever repeat when you're graphing a function. Now, if you look in a physical graph, this just means that a horizontal line will only cross the graph one time. If you remember, before we had the vertical line test, now with a one-to-one function we have the horizontal line test. As an example, suppose we have f of x is equal to the square root of 6 minus x squared. If you were to type this in a calculator, it's going to give you a semicircle. It's going to go on the left side, it's going to curve up, curve down to the right side. Now, if we go to our horizontal line test, and we draw a horizontal line across, it's going to touch two times, once on the left and once on the right. Now, since it touched twice, then the horizontal line test fails because it's only supposed to touch once if it's a function, one-to-one function. So in this case, it's not one-to-one. So if you have a graph, horizontal line touches more than once, it's not one-to-one. If it just touches once, then it is one-to-one. Okay, now if we're looking at just a set of points, if our function is 1, 2, then 3, negative 1, 5, 3, and 6, 4, to get the inverse, all you do is invert the points. The y values become the x values. They just change places. So 1, 2 turns into 2, 1. You just invert them. 3, negative 1 turns into negative 1, 3. 5, 3 turns into 3, 5. 6, 4 turns into 4, 6. We just transpose the places. So that's what's going to happen if we have a number line or a chart. Now, on a graph, if you take these points, this point right here is, suppose it's over 0, up 1, and you transpose that, it's going to turn into 1, 0, which is down here. And all these points just wrap across. So basically, if you'll draw a 45-degree line, y equals x, and then each of these points wrap across that line, way out here is going to wrap over there, and it's not quite perfect. This wraps down there, this point wraps over to there, and so it's symmetric about that line. Sorry, that was the best I could draw. But that's graphically what happens when you have a inverse. And then if you're actually physically checking inverses, what you're going to do is compose the two functions, so f composed with g. When you do that, you should get the letter x. Now suppose we have 2x minus 1 and x plus 1 divided by 2. We want to find out, are those inverses? So what you do is compose them. Okay, you take the x plus 1 divided by 2 and you put it in where you see x, which is 2, and then x plus 1 divided by 2 minus 1. So we took this bottom function, x plus 1 divided by 2, and we put it in where we have this x. Now if you multiply, these will cancel, and you get, once those 2's cancel, x plus 1 minus 1. And the 1's cancel, and you get the letter x, which means, yes, they are inverses. Now suppose you have x squared minus 3, and the square root of x plus 3. Now we have to have a restriction because this is only defined for positive numbers. So in this case, I decided to restrict it to 0 to infinity, because 0 is positive in this case. So suppose we do our composition. If we take our g function, our square root of x plus 3, and put it in for our x, you get the square root of x plus 3, this function plugged in right there, squared minus 3. Now your square and your square root cancel each other out, so you have x plus 3 minus 3, which makes x. So because of this restriction, which gave us a g function which did work, those are indeed inverses. Okay, now if you actually want to physically find an inverse, to do that, what you do is, like the word says, you invert everything. Suppose you have 4x plus 8. What you do is invert, this is f of x, you turn it into x. For y plus 8, you change places of everything. So this was y equals 4x plus 8. You change the x and the y around, so it's x is equal to 4y plus 8. We're inverting things. Then you solve it for y. And when you do, if you move the y over, that's negative 4y. Move the x over as negative x plus 8. And then when you divide by 4, or negative 4 rather, you have negative x divided by negative 4 is x divided by 4. 8 divided by negative 4 is negative 2. Now suppose you have g of x is square root of x minus 3. Do the same thing. That's the same as y equals the square root of x minus 3. We do have to put a restriction on it. X has to be bigger than 3 because we want a positive number under here. Switch places. X is equal to square root of y minus 3. Then solve it by squaring both sides and moving the 3 over. And you get x squared when you square both sides. And when you move the 3, you get plus 3. So that is the inverse of what you started with, square root of x minus 3. So to find inverses, switch the letters and then solve for y.